In this video, we'll look at the in-class investigation. Now, firstly, let's look at the syllabus. Trigonometric function 3.1.5 establish the formula. The derivative of sin x equals cosine x, and the derivative of cosine x equals minus sin x. By graphical treatment, numerical estimation of the limits, and informal proofs based on geometric construction. Okay, so that's why in this in-class investigation tool, we try to fulfill the requirement of 3.1.5. Okay, we'll go through a few activities to establish the derivative formula for sin x and cosine x. Now, number one, you need to use your graphing calculator to complete the following tables. X is in radian, and give your answer to 5 decimal places. Okay, so let me show you how do I get those values. Now, firstly, in the setting, cancel. Okay, firstly, in the setting, firstly, in the setting, number 2, document setting. Sorry, the reason I made this mistake because I keep double clicking, just single click. Okay, you see the setting. Angle is assumed to be in radian form. Okay, so don't change this setting. So keep the angle as radian form. Cancel. So setting, document setting, radian. Always change. Always leave in radian. Okay, display digits. Row 6. This one we just don't change anything. Okay. Keep that. Okay, cancel. Now let's calculate. So where do we find the cosine sine function? Is here. Trigo, T-R-I-G. Okay, T-R-I-G. So click this button, cosine function. Okay, and then cosine 0.1. So simply put cosine 0.1. 0.99500. Okay, so 0.99500. 0.99500. And please take note, 5 decimal places. Okay, and also, do you remember cosine x is equal to cosine negative x? So here we know it's also 0.99500. Okay, now cosine 0.01. So move the cursor on top, enter. So duplicate the function, then change to cosine 0.01. 0.99995. Same as cosine negative 0.1, negative 0.01, also 0.99995. Okay, change to equal to 1. Okay, so here I think you can imagine now, as x goes to 0, the limit of cosine x is equal to 1. And for this one, we can simply sub 0 into the cosine function. Okay, the easiest way to find the limit is by substitute the value into the function. So x goes to 0, we sub 0, we get cosine 0. And cosine 0 equal to 1. Okay, please take note, sin 0 is 0, tangent 0 is 0, but cosine 0 equal. Okay, second one. Now this one, right, you cannot really sub 0 inside because that will be 1 minus cosine 0 over 0, which is 1 minus 1 over 0. And you cannot move on. What is the value of 0 over 0? No. So This time we have to check the values here and then to guess the limit. 1 minus cosine x over x. Okay. So I'm going to get a fraction, and we'll get 1 minus cosine 0.1 over 0.1, right? Double check, 1 minus cosine x over x. So 1 minus cosine 0.1 over 0.1. Enter. So here we have 0.049958. If I'm not mistaken, this is also 5 decimals, okay? So that is 0.04996, right? 0.04996. Okay, 0.04996. Okay, how about if I change to negative 0.1? Okay, remember to put negative sign is this button. Oh, just negative. Negative 0.04996. Okay, that is because cosine x equals cosine negative x. But this x also changed to negative x. So the value will go to the opposite side. Now let's change to 0.001. 0.005. So I believe this one is also negative 0.005. Let's double check. Change this to this. Yeah. Okay, so now I changed 0.01 to 0.01, 0.001, 0.0005. 0.0005. So I believe this one is negative 0.0005. Okay, as you can imagine, this limit seems to be going to equal to 0, right? Okay, it looks like the limit is going to be 0 because as x approaching 0, the 1 minus cosine x over x is getting closer and closer to 0. No matter from the positive side or from the negative side, it's approaching 0. Okay, but we have a graphing calculator and we can verify it by ourselves. So I just find the limit this time. X goes to 0, and the fraction is 1 minus trigo here, cosine x over x. Okay, I just directly calculate the limit. Yes, it's equal to 0. Okay, the graphing calculator verified that the limit of 1 minus cosine x over x equal to 0. Okay, so the limit of cosine x is 1. The limit of 1 minus cosine x over x is 0. And then the limit of sin x over x. So here, once again, we get a fraction. We put, this time is sin x. Okay, sorry. 0.1 over 0.1. 0.99833. Okay, 99833. So this one is. Okay, 0.01. 99998. Wow. Okay, how about 0.001? Oh, just one. Okay, just one. Okay, what if I put a negative? Wait, also one, huh? Okay, what if I put negative 0.01? Negative 0.01. Negative 0.01. Same. Okay, so what happened is this, in fact, there's a reason. Okay, because when you put the negative x, as you know, the sine negative x is negative sine x. So that's why it's equal to sine x over x. And then you can see as x approaching 0, as x approaching 0, the sine x over x is approaching 1. Okay, and this one also we cannot sub-zero into it, because sine 0 is 0. 0 over 0 you cannot calculate. But by looking at the table, we'll see the sine x over x has a limit of 1. And we can verify here. Limit x goes to 0. Fraction. Sine x over x, yeah, equal to 1. Okay, so just now we did the first part, 3 tables, and we established 3 limit expression. The limit of cosine x equals 1. The limit for 1 minus cosine x over x is 0. And the limit of sine x over x equal to 1. Okay, let's just stop here first.